Hello and welcome to my video 7.3 on similar polygons. So it could be irregular shapes, doesn't have to be squares or circles or rectangles or triangles, any of those. It can be something a little bit more irregular like this. So we're looking at all the different shapes here in green and we're trying to figure out which ones are similar. Well, this is a little bit tricky. Okay, they all have similar, so they have an angle, then they have flat on top, flat on back, and flat on bottom. So, and they all have the same number of sides, but two of them are more similar than the others, and it's the actual mathematical definition for the word similar. So let's take a look here. Our bottom has 4. Our bottom on this one has 4, so that means, it could be similar, but let's look at the rest. We've got 2, 2, 1, 3, and here we have 8, 4, 4. Okay, without looking at that angled side, can we figure out which ones are similar? Well, these ones are. Okay, so you actually just multiply by 2 from the first one to get to from the left one to get to the right one. So 2 times 2 is 4, 4 times 2 is 8, so this is how we get there. So they are similar to each other. So this is sort of the idea that both have the same ratio of all the sides. Okay, so you can sort of see that, and I'll talk about it in a different way in a second. But let's try another example first. So here we have these red ones, and which ones are similar? Pause the video if you need to. Okay, I'm going to let you know which ones are similar. So if we look here from the part where it goes and starts to curve or starts to angle, let's see how long that is. Here it's 6, here it's 3, here it's 4. Okay, well, without knowing anything else, it could be. Now let's look at this distance from here to here. That's 1. From here to here, that's 1. Okay, this one's 2. Okay, this one here is 1 again. This one is 2. Okay, we can start already seeing which ones are similar. So you can see that the 3 to get to the 6 is times by 2. The 1 to get to the 2 is times by 2. So these two on the left are similar. Okay, and let's take a look at this last example of this basic type and try to figure out which ones are similar. Well, this is how we're going to figure this out. So this to here has 2. This to here has 2. This to here, we're going to call it 3. This to here is 2. It's not really 2, but you can see that it's from this point to this point to this point. So it's kind of like 2. And then from here to here is 1, 2, 3, 4. Oh, I think this is, none of them are similar, it looks like. So maybe I made a mistake. Just hold on, let me adjust that. There you go. Now, 4, 4, 4. So you can see that these now have a different ratio, 2 over 3 you could say, whereas this one here has 2 over 2, and this one and this one have 4 over 4. So you can sort of see that this ratio is starting to come out, and the sides are multiplied by 2, you could say, to get from one to the other. Okay, let's continue to look down here, and let's take a look at the ratio and see if we can use that to help us determine which one is, which ones are similar. So here we've got 2 by 2. So let's go 2, oh, looks like that setting's on, so 2 over 2. This one is 3 over 3. Now there isn't any easy way to multiply between those, except by a fraction. But you can see that the ratio is the same, so they are similar. 4, 6, so 4 over 6. Now our ratio is different. So you can see that these two are similar. Okay, and last one here, we have, I'm going to go with base and height. This here is also 4. And the base here is 6. And the height is 6. The base is 2. Height is 2. So if we go 4 over 4, 6 over 6, 2 over 2, actually all of these are similar to each other. So you can start seeing that maybe a ratio might help notice if they're similar. Okay, I hope that this video helps you understand similar polygons. Good luck.